All right, we were talking about the zodiac constellations being the constellations that the sun passes through each year as it goes around the celestial sphere. And the problem with this is the sun's axis, you see it's tilted 23.5 degrees. That tilt doesn't change much, but the position that is pointing on the celestial sphere rotates. So you can imagine it's like a spinning top. It goes around like this. And over time it changes which constellations the sun is going through at the specific time of year. Now it's a really slow effect, and we have a name for this. We call this precession. And it takes 26,000 years for one complete revolution of the Earth's axis. Okay? And so this is the 26,000 year rotation of Earth's axis of rotation. All right, what's that have to do with zodiac constellations? Well, right now, we are currently in the age of Pisces. What that means is the vernal equinox, which is where astronomers measure everything from the vernal equinox. This is our reference point. It's kind of like the prime meridian on the Earth. The vernal equinox is the reference point on the celestial sphere. Well, the vernal equinox, right now, is right here, and it's in the constellation of Pisces. This is Pisces right here. Okay? And this is where it crosses. You can't probably see it very well on the video, but right there's where it crosses. It's currently in the age of Pisces. Well, over this 26,000 year period, that vernal equinox keeps shifting constellations. And over 26,000 years, it goes through all 12 constellations. And so each age is roughly 2,000 years. Right? Because 12 times 2,000 is 24,000. It's close, a little bit more than 2,000 years. Well, we are in the age of Pisces. However, the next constellation is the age of Aquarius. And so I don't know if you heard of it, but back in the 1960s they had a hit song called The Dawning of the Age of Aquarius. That's what they're talking about, is the vernal equinox is shifting over time into the constellation of Aquarius. Now, the problem is it's like 700 years. The dawn is a long time. So when you're saying the dawning of the age of Aquarius, we have a while to go. Pisces comes all the way out here. It's shifting this way. Aquarius is over here. It's going to take 700 years for this to rotate over to the point where it's hitting Aquarius. So it's going to be a little while. What it did do is, if you're into horoscopes, is it messed up your horoscopes too, because most of the horoscopes were outlining the dates for when the sun was in those constellations were determined over 2,000 years ago. And the astrologers that study these things use those same charts. But they didn't account for the fact that the Earth's axis precesses. And when the Earth's axis precesses, it changed where the sun is. So, currently, if you think you're like a Leo, you're not really a Leo. Because the sun isn't in Leo on the day that they claimed that it was. Because of precession, 2,000 years ago, well, 2000 is about 1/12, all of the constellations have shifted by 1. So if you think you're a Leo, you're not really a Leo, you're actually a Cancer. If you think you're a Cancer, you're a Taurus. You're one ahead of where you think. If you think you're a Taurus, you're an Aries, and so on. And so I always tell everybody, well, if you read your horoscopes, just read them all and pick whichever one you think fits you and makes you feel the best that day and call it good. Because it's about as accurate no matter what. So, all right. That is precession. I'm going to put a link up to a YouTube video that shows precession and why the Earth is precessing. Look at that YouTube video. It'll show you how the Earth actually spins like a top and why it moves that way. All right, so now we got to figure it out that there's these special constellations, the zodiac constellations, and that the sun moves around on the celestial sphere and it gets higher and lower. What we have to talk about now is coordinates on the celestial sphere. Remember on the Earth, this is the ecliptic. On the Earth we have latitude and longitude. Latitude is how far you are from the equator. And if you remember, the latitude of Commerce, Texas, right here is 33 degrees from the equator. Okay? Latitude is how far north to south you are. We need to have a similar thing on the celestial equator to say how far are things from the celestial equator. We have a name for that. We call that declination. Declination is how far an object is from the celestial equator. Okay. So, let's look at this on our celestial sphere here. The north celestial pole has a declination of 90 degrees. That's the declination. Because from the celestial equator you'd have to go 90 degrees to get to the north celestial pole. South celestial pole has a declination of negative 90 degrees. So anything south of the celestial equator is negative, anything north is positive. So the declination goes from positive negative 90 degrees to negative 90 degrees. Yeah. Unlike latitude that has a north or south after, here it's just positive or negative. Let's look at the sun. So on the vernal equinox, right here, when the sun is on March 22nd, it's in the constellation of Pisces. What's its declination? Its declination is 0. Why is it 0? Because it's right on the celestial equator. Same thing for the autumnal equinox. It has a declination of 0 degrees. Now when we get up here, here's the celestial equator. Remember, the celestial equator always has a declination of 0 degrees. That's how it's defined. But the sun is above the celestial equator, so it has a positive declination. And on the summer solstice, the sun has a declination of 23.5 degrees. Because it's 23.5 degrees from the celestial equator. And down here on the winter solstice, it has a declination of negative 23.5 degrees. All right. So, the sun is tricky because the stars over our lifetime don't change declinations much. They change slightly because of precession, the whole sky changes. But within our lifetime of 100 years compared to 26,000, there's not much change. Astronomers have to account for that, but it's actually very easy to account for. But the sun, through the year, is changing declinations every single day. And so that's why the sun is going higher and lower in our sky, because of that tilt. Yeah? Now we can go back and we can also do this with respect to circumpolar stars. Remember circumpolar stars? We talked about that in the last video. And a circumpolar star, let's figure out, or the question we would ask is, what are the declinations of stars that are circumpolar and let's do from Commerce, Texas. You can do it for any location as long as you know the latitude. How are we going to figure it out? This is very easy. We're going to do our Herb diagram. So we're going to do our Herb diagram that we figured out how to do. You do a half circle. North is always to the left, south is to the right. And then we put Herb in the center. And we know that the latitude of Commerce is 33 degrees north because that's one of the numbers that we've memorized. Which means above the north point on the horizon we go up 33 degrees. That's where the north celestial pole is. Yeah. And then we go 90 degrees away from that to find the celestial equator. So here's the celestial equator. This is 90 degrees. And we already figured out that the altitude of the celestial equator is 57. Right? All that has to add together to make 180. But declination is always measured from the celestial equator, not the north celestial pole. But any star within 33 degrees of the north celestial pole, anything in this region right here, I'm going to draw another line here, 33 degrees on either side of the north celestial pole, is going to be circumpolar. It's just going to go round and around the north celestial pole. So all I have to do to figure out what declination is figure out the angle from the celestial equator, because that's what declination is. So I just need that angle. Well look, this is 90 degrees, this is 33, so it's really just going to be 90 minus 33, which is 57 degrees. So all stars that have a declination greater than or equal to 57 degrees are circumpolar from Commerce, Texas. So it's very simple. You just take 90 minus your latitude. Okay? 90 minus your latitude tells you what stars declination are that are circumpolar. It's also the same thing. If you go down here and you want to see which ones are never visible, well, remember from Commerce, Texas, the ones that are never visible are the ones down here. Well, look, the horizon has a declination of negative 57 degrees because I'm 57 degrees from the celestial equator. So ones that are never visible